this is part 2 of the video for the second day of solving exponential and logarithmic equations. And these two learning targets are focusing on finding the intercepts of an exponential function and a logarithmic function. So in general, to find an x-intercept, you plug in 0 for y and solve for x. In general, to find a y-intercept, you plug in 0 for x and solve for y. Now this is true for any function. It doesn't matter whether it's a line, a quadratic, exponential, square root. This is always true. Now sometimes you will not get a solution which tells you that you do not have an x or y intercept in that situation. So now let's scroll down and look at the three examples we have below. So the first one, we're going to find the y-intercept of this function. So because we're looking for the y-intercept, I'm going to plug in 0 for x. So y equals 3 to the 0 minus 6. Now here, we're just going to follow the order of operations to evaluate. And I personally think it's actually really important to make sure you write it this way, because a lot of times people plug in 0 and think everything goes to 0. That doesn't happen here. When you have 3 to the 0th power, that's going to equal 1. So now we have 1 minus 6. That means my y-intercept is going to be a negative 5. For number 6, we're going to find the x-intercept, so that means we're going to plug in 0 for y, and we're going to solve for x. So first of all, I'm going to move this 128 to the other side. So we have 128 is equal to the x. Now, I happen to recognize this as being a power a 2. So I think it's helpful to just use that tool, so we're going to do that. Now, I'm going to list the powers of 2 so that we can figure this out. So 2 to the first power clearly is 2. 2 squared is 4. 2 cubed is 8. So I'm just multiplying each previous number by 2. 2 to the 4th is 16. 2 to the 5th is 32. 2 to the 6th is 64. 2 to the 7th is 128. So that's where we're reaching. We got to the number we wanted. So I can rewrite this as 2 to the 7th is equal to 2 to the x. So that means x is equal to 7. So the x-intercept is 7. Looking at the last example here, we're going to approximate the zeros of 3 to the x minus 6. Now remember, zeros and x-intercepts are not exactly the same, but they're pretty close to being the same. If they're both real values, then they're going to be the same. So get your calculator out. I'm going to show you guys another way of doing this problem. So first of all, we're going to go to y equals and type in the equation, and you can see that I already have it typed in. Now, please be sure to double check your window to make sure it has something where the image of the graph is actually going to be visible on the screen. So I have from negative 10 to 10, and the same thing for the y's. So press graph, and you might have to wait a moment because mine's already there. Now hopefully you remember how to find a 0 on your calculator. I'm going to press second, trace, and I'm going to select option number 2 to find the 0. And I make sure my cursor is to the left of the 0, press enter. And move my cursor so that it's distinctly to the right of the 0, press enter again. For some reason it says guess, press 0. And so we have a 0 at approximately 1.63. Now keep in mind, we just finished this example, but we could have done number 6 exactly the same way. So if for some reason you're allowed to use your calculator and this isn't going to be obvious to you, finding the powers of 2, you can use your calculator. If we wanted to, we actually could have done the first example the same way. So this actually is the same function. And if I wanted to, I press second, trace, to access the calculate menu. The first option says value. So if I press enter, I can type in a value for x, and the calculator will generate the value for y, which is exactly what we got. So we got the same thing as what we have for example number 5. So at this time, please write yourself a summary and actually write any other questions down that you may have, and also complete the extra examples. Try these problems on the next page.